Hello students, I hope you are all well. We are starting with midpoint theorem now. Okay, so हम लोग start करते हैं. We have completed exercise 8.1. This is exercise 8.2. Your topic number is 8.6. That is midpoint theorem. Now, first thing you need to consider is that in the first part of the chapter, we were discussing about the quadrilaterals, the parallelograms, the trapezium, the square, the rectangle and rhombus. We have discussed about their properties, the theorems related to them and how to prove them. Okay. In the second part of the chapter, it is mainly focused on triangles. But this part of the chapter was not combined with the triangles. The reason for that is we are going to use this theorem, this midpoint theorem, that is applicable for any triangle and only for a triangle to prove certain quadrilaterals. Okay, जब आप क्वेश्चन करेंगे you will understand the questions, you will understand what I am trying to say. Okay, so we will start with the theorem. And one more thing, the proof of these theorems are no longer part of your syllabus, so you just need to remember the statements. Okay, understand the theorem and remember the statements. So we'll start with it. First of all, for any triangle, I am drawing a triangle. Okay, you can have any sort of triangle. It can be a right angle triangle, it can be an isosceles triangle, equilateral triangle. So for any triangle, this theorem says that a line passing through, let me draw this line through the midpoints of the triangle. Okay, you have a triangle ABC, a line L is passing through triangle ABC such that it intersects point P and Q, and P and Q are the midpoints of this triangle. See, for triangle ABC, P and Q are midpoints of two sides of this triangle. Okay, if such thing happens, if we draw such line which passes through two midpoints of a triangle, then that line is going to be parallel to the third side. That means PQ will be parallel to BC, and also that line is going to be half of it. Theorem is stating that if you join midpoint of any two sides of a triangle, then that line will be parallel to the third side of the triangle and also half of it. Okay. So this is the statement: the line joining midpoints of any two sides of a triangle is parallel to the third side, and let us extend this statement, and is half of it. Half of it. Okay. So now in triangle ABC, we can write down as if P and Q are midpoints of AB and AC, then what will happen? First of all, PQ line will be parallel to BC, and secondly, and PQ will be half of BC. Okay, these two things will happen. If on joining the midpoints of any two sides of the triangle, the line we get is parallel to the third side of the triangle and is half of it. Okay, this is the midpoint theorem for you. Next is converse of midpoint theorem. Converse of midpoint theorem is a line passing from midpoint of one side of a triangle parallel to the second side will bisect the third side. Okay, this is triangle ABC. P is midpoint of AB, and there is a line that is passing from P and is parallel to BC. There is a line that is passing from B and is parallel to BC. Okay, let's say this line intersects AC at Q. So what the theorem is stating is, if in triangle ABC, if P is midpoint of AB and PQ is parallel to BC, midpoint of one side of the triangle parallel to the second side, then PQ, sorry, then this Q point is midpoint of AC and PQ is again half of BC. Okay. So in triangle ABC, keep that in mind, we are only talking about a triangle. For any triangle ABC, if P is the midpoint of that, P is the midpoint of any one side of the triangle and line passing from P is parallel to second side of the triangle, then that line will pass through the midpoint of third side of the triangle ABC. Okay, here P is the midpoint of AB and PQ line is parallel to BC, then that means by converse of midpoint theorem, Q will be the midpoint of AC. Okay, once again, proof of this theorem, although it was important until last year, but this year due to coronavirus pandemic, 30% of your syllabus has been reduced. So we are not doing so this theorem part is also decreased. Okay. So basis on these theorem, we will start with the questions. Okay. Question number 1 and question number 6. I have written down question number 1 and I have taken question number 1 and question number 6 together because first of all, let me explain the question to you. The point I will be making is that solution of question number 2 and question number 1 is exactly same. So if I am telling you the solution of question number 1, you have to do the same solution for question number 6 as well. And as we will move on with the exercise, you will come to know that all of the questions in this exercise are quite similar. Okay, their steps of solution are quite similar. So in earlier questions I will explain it properly, and then as we move on with the exercise, I will leave some part for you that was related to the previous questions. Let's start with question number 1. Question number 1 is ABCD is a quadrilateral. ABCD is a quadrilateral, as you can see in the diagram. PQRS are midpoints of sides AB. P is the midpoint of AB. Q is the midpoint of BC. R is the midpoint of CD, and S is the midpoint of DA. And we have also one diagonal AC. First of all, we have to prove that SR is parallel to AC. We have to prove that SR is parallel to AC and is half of it. Second, we have to prove that PQ and SR are equal. We have to prove that PQ line and SR line are equal. Lastly, we have to prove that PQRS is a parallelogram. Okay. So what we have to prove that lines joining midpoints of sides of quadrilateral form a parallelogram. Okay, line segment joining midpoints of opposite sides of a quadrilateral bisect each other. Okay, this is question number 6. Question number 6 is you have to prove that lines joining midpoint of opposite sides of the quadrilateral bisect each other. In question number 6, you will draw the same diagram, but only difference will be you have to join PR and SQ. Okay. So in question number 6, question is essentially asking you to prove that PQRS is a parallelogram. Why so? Because you already know the diagonals of parallelogram bisect each other. So inside the quadrilateral PQRS, if you prove PQRS is a parallelogram, then the next statement will be, since the diagonals of parallelogram PQRS bisect each other, then the next statement will be, we know that diagonals of a parallelogram bisect each other. That means line joinings midpoint of opposite sides of the quadrilateral will bisect each other. Okay. So moving on with question number 1. Question number 1 is ABCD is a quadrilateral. Okay. And we will move on with the question one by one, step by step. Please follow the steps carefully. Question number 1. ABCD is a quadrilateral in which PQRS are midpoints of sides AB, BC, CD and DA. Okay. So, first of all, we will write down what is given to us. What is given to us is in quadrilateral ABCD, in this quadrilateral P, Q, R and S are midpoints of sides AB, BC, CD and DA respectively. Okay. Next is to prove. I am not writing to prove because you have to prove all these three things. Keep in mind, for every question you have to draw the diagram, you have to write given, you have to write to prove, and if there is any construction you have to write that as well. Okay. So let us start with the question. First of all, first of all, we will divide this quadrilateral into two sections. First of all, I am going to take the section above the diagonal AC. This is ADC. In triangle ADC, S and R are midpoints of sides DA and AC. In triangle ADC, S is midpoint of AD and R is midpoint of CD. Okay. So by doing this, by midpoint theorem, what you will have is SR will be parallel to AC, first equation, and SR will be half of AC, second equation. Okay. Similarly, we will take the triangle below the diagonal, that is, this is A, this is C, there is B, there is P, there is Q. Okay. Next is similarly, in triangle ABC, P is midpoint of AB, Q is midpoint of BC. So, by midpoint theorem, we have PQ parallel to AC and PQ as half of AC. This will be third equation, there will be a fourth equation. Now, in equation 1 and 2, you can see that SR is parallel to AC and PQ is parallel to AC. So, we will say that two lines parallel to the same line are parallel to each other. And using equation 2 and 4, SR is half of AC and PQ is half of AC. So, we will say that two lines equal to the same line are equal to each other. So, now, by equation 2 and 3, 2 and 4, SR is equals to PQ is equals to half of AC. Okay. And by equations 3 and 1, SR will be parallel to PQ. How so? Two lines parallel to a same line, the same line, are parallel to each other. Okay, so using this, now what we have is, we have for quadrilateral PQRS, one pair of opposite sides are equal as well as parallel. So we'll write for quadrilateral PQRS, since one pair of opposite sides are equal as well as parallel, so PQRS is a parallelogram. So PQRS is a parallelogram. Okay. So with this we have completed question number 1. Question number 2 I leave you to do by question number 6 I leave to you to do by yourself. That will be your homework. Okay. In the next video we will discuss further questions.